Good morning. So let me get a show of hands. Who is an owner-operator? Okay, perfect. Who is a contractor? All right, and who's like a product manufacturer / engineer? All right, perfect. So like thirds. Great stuff. Hey folks, I'm Phil Zito, CEO, Smart Buildings Academy. Today we're going to be going through Building Automation Unveiled, and what we're going to be covering is a couple different things. So first off, we're going to talk about, what is building automation. This is going to be important from the aspect of it's going to be talking about why you would use one, how you communicate the value. So for those of you on the owner and engineer side that actually have to go and sell this up or sell this through, that's going to be valuable for you. Then we're going to be talking about architecture. I'm going to be pointing out key terms so that way you all are speaking the same language. So on the contractor side, when you're talking to your owners or engineers, you all are speaking the same language. On the owner side, when you're looking at OEMs, O and M's, it's been a week. So when you're looking at O and M's, you'll have an idea of what the terms mean. From there, we'll go through BAS components. Then we're going to talk in depth about how BAS projects are executed, and then we'll do live question and answer. Okay, so this is really important. We've got an hour here. It's early in the morning. The more questions you ask, the more you engage, the more you'll learn. This is like an hour of free consulting. So literally just ask anything you want. If I can't get you an answer, I could probably point you to a resource for that. Fair enough? All right, let's go. I'm going to skip over this because I already went through who this is for, and we're going to go to what is building automation. All right, so I heard Scott telling this story earlier, so I'm going to give kind of a brief history. It's important for us to understand. Can you all still hear me good enough? Yeah. Is that good?
So we got a traveling mic if you want.
Oh, no. Pace aisles and stare awkwardly at people. There we go. Hello. I'm here all day. All right, so building automation started off, so kind of in the 70s, we had electromechanical controls. Who has a thermostat at their house? Makes that clicky noise when it turns on, turns off, right? Electromechanical controls, right? So temperature element expands, contracts, makes the contact close, turns on heat, turns on cooling, turns on fan, all that great stuff. So in the building automation world, you had pneumatics, you had electromechanical controls. Someone way smarter than myself figured out there's this thing called direct digital controls. What it did was it took those analog signals. Analog just simply means numeric. It's not on, off. It's not Boolean. It's analog. So they took that data and they were able to convert it to what is called Boolean, right? It's on, off. Or digital, what a lot of people call it. The reason I'm using all these terms is as you work with building automation systems, you're going to hear analog, you're going to hear digital, you're going to hear Boolean, you're going to hear numeric, you're going to hear all sorts of terms that mean the same thing, but every company in a great conspiracy to confuse all of you decided not to use the same terms. So supervisor means router, which means supervisor, which means gateway, all this fun stuff. So in the world of building automation, what happened is someone decided, hey, we can take this analog to digital converter. We can convert temperature signals that are analog, right? And we can convert them to digital, which then means that we can take that signal into a computer and we do all sorts of cool things. We can program things, we can make things blink, do all sorts of fun stuff. But then they realized, oh crap, you can do all this stuff, but just like with pneumatics, is it cutting in and out, or is this me? Am I moving it? Okay. All right. Here we go. We'll see if this works. If it does, I'll just get rid of it. So, like I was saying, the pneumatics, you can't see what's going on. The electromechanical, I mean, I guess you could with an accumulator, but it's hard to see what's going on. Well, the same problem existed with DDC. Couldn't really see what was going on in the controllers, so we created what was called a supervisory device or a gateway, and it ran communication wire to all these devices, and now we could pull all these devices into a device that then sent it to a computer and would give us what's called a graphical user interface. So we could see what was going on, and then a star was born. So building automation was created right around late 70s, 80s, and generally just progressed into what you have now, which is, because at first, and Scott, we were talking about this, we were talking, Ryan, right? Yep, so we were talking with Ryan about it. And at first it was like only the OEMs had this. They were the only ones. OEM, who knows what an OEM is? Who does not know what an OEM is? Cool. All right, cool. So they were the only ones who had building automation. And so you couldn't buy it but through anyone but them. Then Niagara came out. Niagara was a software framework that could be put into any device. And so that opened up what was called a secondary channel. So primary channel is through branches. Now you have a secondary channel, so you have contractors who then can go and deliver either service or install building automation systems. So from there, right, we got this open procurement, and I'm going to use these terms because so many people get caught up with what is open. How many of you get asked, is it an open system? Or you ask, is it an open system? All right, so since you're in the front, we're going to pick on you. When you're saying that, what do you mean? So what does open mean to you?
So the
And there's no right answer.
support channel is not closed to a particular region, like
Mhm.
a rep of that service
Mhm.
or that brand, so that you can then buy parts and pieces.
Got it.
Do programming
Perfect.
locally.
Open procurement. So open access to the product. So we just heard open procurement. A lot of other folks will say it's open in that I can put another product on the field bus and I can pull it in. That's open protocol. Other folks will say I have access to the software. That's open tools. And then other folks will say I can pull data out of it and pull it into a different system. That's open programming interfaces or APIs. So we're already starting to see the word open is loaded. So when you put it in a spec and you say it's an open system, what does that mean? Well, what happened, right, going back to this example, is now contractors on that secondary channel can bring product out. And now, as you walk the floor, you're starting to see kind of the next generation of building automation systems pop up as well. You're starting to see names you knew, names you didn't know. And a lot of them are using Niagara interface. A lot of them are using other interfaces. Now, why do I tell you all of this history? I tell you this so that as we go through this architecture, if you understand where we've been, you understand where we're at, you'll understand where we're going, and then as owners, you'll be able to ask better questions like, hey, I see this spec says it's open, and I really want the software tools, so is it open software? Do I have the software? Do I have full administrator rights to the software? All those things. As an engineer, you're specifying a system, it's open protocol, or is it? At what layer is it open protocol? These are all the things I want you thinking about. All right, let's get into the show. So these are all building automation systems. So right there, you have a supervisory device, you have a field controller, you have just a smart thermostat right there. But all of these have the capability of taking inputs, driving outputs, and communicating to some form of user interface. In the case of that smart thermostat, the user interface is right there on the thermostat. In the case of that controller, it's got some HOA on it, but it would use a COM bus, which we'll talk more about later, to go back to a supervisory device to go to your server or client. Any questions so far? Have I lost anyone yet? No. Good. All right. So this is the problem, right, that I was kind of talking about. It leads to a lot of confusion, people sitting sadly in corners because they specified a system that doesn't work, or they bought a system that they thought was open and it's not. By the end of this, you should have a couple things in your tool belt that'll help you navigate this. This is what I would like you to ask if you are a contractor, if you're an engineer, if you're an owner, these three questions. So right now, if you are considering retrofitting or adding a building automation system, are your business processes being affected by environmental conditions? Are you getting regular visits from the Joint Commission if you're in healthcare because people are getting infected on the OR table? Are students, passing out because CO2 is at like 3,000 parts per million and they're just like passing out on the desk? These are all things that might make you want to consider putting in some form of control in your facility. Have you honestly done everything you can do with existing systems? Like, seriously, go walk to the piece of equipment, make sure the actuator is actually on the damper shaft. Go take the 2x4 out of the outside air damper, things like that. If you've done all that and you can't operate your building, then you should, in my opinion, consider either upgrading or purchasing a building automation system. I don't sell building automation systems, so I can say that pretty unbiasedly. All right, so what do you want to know? And this is going to be the last slide before we get into the architecture where I fully expect, man, my voice does not carry that much. Before we go into the architecture, and I expect you all to ask a lot of questions. So what do you want the system to do? Do you want to be able to access it remotely? Do you want to be able to program it? Do you want to be able to change the graphics, add points, add or replace controllers? Do you want it to have automatic commissioning? Do you want analytics sitting on top? What do you want it to do? Does it need to interface with an existing system? How many of you are owners again? Now, so this is the circle of trust. Everything that happens in this room stays in this room. How many of you have not updated your O&Ms, but you have changed stuff in the past 10 years? Circle of trust. One, come on. Golf clap. All right, gotta keep it quiet, we'll get kicked out. So, first off, thank you for being honest. Like, seriously, we were doing a RFP for a large community college. They wanted to do a PSA. They basically wanted to contractually commit their controls contractor to exactly what maintenance tasks they were doing rather than using them as 8 hours of free/paid labor that they would come and do. But in order to do that, they needed to know what control systems they had. So I built out this beautiful RFP, sat down with their 4 superintendents, and they're like, yeah, that doesn't have a control system. Well, you said it. Well, yeah, but it doesn't because we ripped it out. Oh, that one actually does. We just put it in. None of their O&Ms were up to date. So first off, figure out what you have. Does it need to interface with something? So engineers, when you're doing any owner direct work, when you're doing any retrofit work, contractors, when you're doing any owner direct work, go and physically verify what's there, look at the system, ask them if it's online, figure out what do I need to interface with. Then, how self-sufficient do you want to be? So Stanford University, they act as a contractor and they bid against other BAS contractors on all controls projects. University of Virginia is doing their own 400,000 square foot medical office building. And then there's a lot of people who just self-execute, or self-service. So how sufficient do you want to be? And contractors, how sufficient do you want your owner-operators to be? If you're only doing construction, you may want to enable them to, I think you should do service. It's great margin. It's great just connection with your customer. All of you should have a service business, but that's a different session. But enable your customers. If they use the BAS, they're going to buy more of the BAS. It's kind of counterintuitive. People are, for whatever reason, like, I don't want to give them access. I don't want to teach them how to use it. They will buy more. Any owners agree that you would buy more if you use something? Okay, yeah. All right, and then are there existing standards for selecting systems? Engineers, owners, and contractors in this room, please help each other write building standards, naming standards, graphic standards, sequence standards. Like, just use ChatGPT. It's so easy. Just literally say, write me a standard for a school, and then it'll get you 80% of the way, clean it up, and slap 40% margin on it and go sell it. So, hey, I'm here all day. All right, building automation architecture. Not that anyone would ever do that. Okay, server layer. This is a server. So what this does, I want you to picture, what analogy? I'm not going to use an analogy. If you can understand this 4-tier architecture for building automation, and Scott, are we going to give everyone these slides? We can, right? Like, they can reach out to you, get them, or
If you're okay with
I don't care. Yeah.
They'll be available on automatedbuildings.com maybe a couple days from now.
Okay. So, save you all having to try to do that awkward picture and it doesn't focus or there's glare and all that jazz. Okay, so if you understand this, you now understand lighting architecture, audio-visual architecture, access control architecture, video surveillance. Every control system in a building uses this exact same architecture. It's going to be server, supervisory layer, field controller, inputs, outputs. And I'll give you an example as we move through each one. But what this does, this is if you have 4 to 5 or more buildings, you're probably going to have a server. What a server does, so remember the supervisory device I talked about earlier, how you had field controllers, but they couldn't communicate, so we had communication buses, and those went to this device called a supervisory device. Unless you're automated logic, then it's called a router for whatever reason. But supervisory device. So let's do some deductive reasoning here. When we take the word supervisor, I think of someone who tells things what to do, but also observes what's being done, right? Everyone agree? So what a supervisory device does is it tells the controllers what to do, so that's where your commands are routed through, and it also observes them. Well, the problem is a supervisory device only has so much compute in it. It only has so much work it can actually do just to resource limitations. So when you have multiples of these, typically 5 or more, you need a server. So a server will then serve resources. So you'll have a user interface. Any of y'all go to Google? Okay, good. If you're like, no, what's Google? Okay, all right, we'll help. So the server, what it does is it serves resources. So you'll have a graphical user interface. That'll have your graphics, your points, your commands, your schedule objects, etc. You will click into that, and then that will go and enable you to interact with the field controllers and their inputs and outputs. But how it works is you have the server, which goes to the supervisory devices. I don't have a whiteboard, unfortunately. Which goes to the field controllers, which goes to the inputs and outputs. Y'all with me? Any question, anything I said that like wasn't clear? This is for you, not for me, so this is your chance. No? Absolutely. Okay. So server, right? And we're going to go through this in slides too. Server is going to take all of the information from the supervisory devices. Each supervisory device is going to have a field bus, sometimes called a field trunk. You'll hear those terms used interchangeably. Those field trunks will then communicate with the controllers. And the controllers, those are usually one-to-one with a piece of equipment. So like an air handler has a controller, a chiller has a controller. Depending on time, we may get into embedded controls, but probably not. But each controller then has inputs. Inputs are data coming in, temperature sensors, low temp switches, pressure sensors, etc. And then it has outputs going out, which those will be commands to valves, commands to relays, commands to drives, etc. Does that help? Perfect. Good question. Layer 2, supervisory device. So the supervisory device originally, this is kind of where we go back to circa late 1990s, early 2000s. Originally, the supervisory device would just do the supervision of the field buses and would go and pull the data from the controllers into the supervisory device and then would be hard connected to a server, and the server would be the only way you could see graphics. Now, a lot of these have graphics built in. So for like a single building, you won't use a server. A single building you may use, so you have like a single medical office building. You have a single commercial real estate building. You would use one device, one supervisory device, and off the field bus, you'd have like 50 controllers. And the graphics, alarms, and trends would all sit in that device. So you would IP into that device using a user interface, and then you would be able to change points, you'd be able to monitor alarms, look at trends, etc. Make sense? So now you're seeing that each one of these layers can kind of collapse. So in certain situations, we may not have a server. And we're going to see in certain situations, we actually may not even have a supervisory device. We'll talk through that next. Yes, sir?
The field bus
Great question. So this is a really good question. Tells me kind of where your brain's at. So this is why terms are so important. So if I switch that to calling it a field trunk, does that make you think it's something different than a bus? Because I think what you're thinking is you're like microprocessor, a actual bus, an actual data bridge on a actual circuit board. So that's not what this is. This is RS-485 standard. So this is a serial communication bus that's wired, and it is communicating across two wires, typically 18-2, sometimes 18-3, shielded twisted pair. And these wires go from controller to controller. They're electrically bridged across the controller. So if a controller goes down, then the signal will continue to pass on.
The bus is all that wiring.
Correct. Yep. Does that help? Yeah. So you all see why like terms are so important. He heard bus, and he's not wrong. A bus, a trunk, those can be internal to the microprocessor board. But in our situation, these are the actual wiring that are going from controller to controller. Okay. Field controllers. So once again, we're going to abstract down a little bit. These are the controllers that I talked about that have analog digital conversion. They have inputs and they have outputs. They have relays. We got the functional device guys here. I like to use the RIB U1C to go. Shameless, you guys lunch after this? Okay, cool. All right, yeah. No, seriously though, I like to use like the RIB U1C. Free piece of information. If any of you are driving a motor coil off of your controller, off of your building automation controller, stop that right now. These things cost about $1,000. Y'all's like, I don't know post-COVID, but it was like $13. So it's a lot cheaper to blow up a $13 device because you route 480 through it than a $1,500 device. I need to take a sip of water 1 second. Man. Woo. Okay, so like I was saying, these field controllers, they take inputs and they drive outputs, and they have either programmable software or application-specific software. So for the engineers and owners in the space, that's another question for you to ask when you get a catalog sheet from a manufacturer. Is this an ASC? Or is this a freely programmable controller? ASC is application-specific controller. We're not going to get into BTL listing here, but we could talk about that later. You just pull me aside because there's a whole thing on BACnet, which that would take us down a whole nother rabbit hole. But essentially, so I said you have a supervisory device that can run a building by itself, right? Well, nowadays, you actually have field controllers, which are called advanced application controllers. And these can have graphics in them as well. And they can have field buses on them as well. And those you can put in an even smaller building. Maybe you're talking like literally a pop-up med shop, right? So doctor's office with, central office, 7 patient rooms, split unit, maybe a couple terminals. You would put that on the split unit, and then you would use the COM bus to go to a couple VAV controllers. And so you wouldn't have a supervisory device. You wouldn't have a server. You would just simply have that. And that's kind of where we've evolved. We used to have servers. Then we got to the point where we could do it in supervisory devices. Now we're to the point where on small applications, we can have controller-only applications. Any questions? Yes, sir. On some of them, yes. Some of them have graphics. Some of them don't. Like we do a lot of our training using the Cyper 30 product. I don't think a lot of people carry that anymore, but it was essentially a mid-tier unitary controller that had graphics, alarming, trends, and a field bus in it. Yeah, good question. Pretty much every manufacturer has some form of AAC right now, Advanced Application Controller. And then layer 4. So layer 4, this is the I/O layer. This is going to be right here, our controller. I copied a slide apparently and didn't update that. I apologize. So ignore the text on the left. We're gonna focus on the right. Do not look at the text on the left. All right, so what's going on here is this is input output. This is actual, yes, sir?
There are I/O devices that have Ethernet connections on them.
Yes, I meant, exactly, yes.
It's not completely.
I was just testing, but you the only one.
I'm just helping you out, buddy.
There we go. I'm here all day. All right, he is correct. I was talking with some Belimo folks, I believe, and they were talking about their IP-enabled different actuators, their IP-enabled energy control valves, et cetera. I know you all have a backnet relay. So yeah, I guess technically I was right. There are MAC addresses on some of these I/O devices. But the I/O devices, what they do is they take input data and then they drive outputs. So all of your temp sensor, pressure sensor, et cetera, and there's multiple different types of inputs. This is important for the specifying engineers. This is important for the contractors and the owners. Like there's use cases for each one, like 4 to 20 milliamp. If you've got a lot of electrical and mechanical interference, you want to use 4 to 20 milliamp. If you've got a long run, you use 4 to 20 milliamp. If you don't have a long run, you can use like 0 to 10 volts DC or 1K ohm resistive sensors. There's a variety. All sorts of output types, right? We've got low side switching, high side switching, triacs, internally sourced relays, externally sourced relays, all sorts of stuff. We can dive into that deeper maybe in the question and answer, but just realize that this exists. So any questions about architecture before we go through projects? Don't yawn yet. I'm not that boring, right? No, I'm just giving you a hard time. I was like yawning in the face of one of the presidents of our customer companies. And I'm like, I promise you, you're not boring me. I'm just.
Are the controllers providing analytics users as well as
When you say efficiency analytics, like
like efficiency, like measure occupation and so forth?
great question. So it depends. Some manufacturers have analytics packages that are at the edge, which would be in the controller. Some have them at the supervisory layer. Some don't have them at all. Typically, the I/O device itself is not going and doing the analytics. If at all, it'll sit in the controller. Some folks are using like LiDAR. Some are just using infrared. There's a variety of ways they're doing occupancy counting or occupancy sensing. So it just depends. Like that's really a very product specific question. But the short answer is yes, some do it. The long answer is it depends on the product. Yeah. Good question. Yes, sir. What was that?
The photos on the right, what they did, those are the input devices. The photos on the right,
Yeah.
what are they implying? What are they showing?
Oh, great. So that's a relay, relay. Oh my gosh, wow. I've been doing this 20 years. So that is an actuator. So an actuator is a output device. And basically what happens on a HVAC piece of equipment, you have a shaft, a rod coming off of a damper. And when you change that causes the damper blades to rotate. Or you have a stem coming off of a valve. And as you change that causes the valve to move. So that you can see that kind of little A-shaped clamp in the little nuts at the bottom of it, right? You tighten that down onto the shaft, and then it rotates, and it'll close and open valves or close and open dampers. So that is the output device. That right there, I believe, is an air pressure sensor. I believe, yeah, it looks like 0 to 0.5 inches water column. So that is a air pressure sensor. So you would put that on like a discharge duct of an air handling unit, and you would run 1 to atmosphere and 1 to whatever your low side is, and that would be able to give you a pressure sensing. So that would be an input, and that you see the 3 kind of little screws. You would go and actually connect your wires to that and route your wires to the controller. And that then would give you like a 0 to 5 volt signal that then you would scale to match whatever the pressure reading is from that sensor. Does that help? Good stuff. All right. Let's talk project work. Okay, so this is where I find a lot of people. So if you're not a contractor, if you're an owner, you're at a little bit of a disadvantage because you maybe do 1-2 controls retrofits in your career, and we do them like every month. So it's really important to understand these different phases, and I'll try to pull out highlights and just little tidbits of information because you have a lot from a contractor, owner, and engineer perspective where you can go and actually impact the project as you go through each one of these phases. So selection and specification. Who's familiar with SDs, DDs, and CDs? So, okay, perfect. I would hope you are. That's like your world. So schematic design, design documents, construction documents. Those are all the documents that contractors bid off of, that engineers go and design. And then owners are hopefully seeing if the GC is letting us have access to them so that they can provide feedback and be like, yeah, that's actually what I wanted. So this is the first place on the construction side that owners have influence. They can go and say, yeah, I don't want that sensor there, or maybe I want a different type of controller. I want a different sequence of operations. The closer you get to CDs, construction drawings, the harder it is going to be to change things. I mean, you could change it. It's going to get more expensive. And yeah, he's going like, yeah, show me the money. So it's really important to have your owner's intent clarified with your contractual representative and have that built into the spec and then have that properly translated to your engineered set of drawings. Because once those are fully engineered and the project kicks off, it's going to be really hard because you're going to have a lot of contractors blaming each other, saying, no, this is your responsibility. Oh, no, it's mine. And it's just bad. It just never seems to work. Yes, sir.
In SD, what do you recommend top questions that should be covered? Maybe it's all dependent on the project.
From who?
From the owner's perspective.
Okay.
What does the owner need? Or provider, owner's rep.
Okay, if I was the owner, first question I would ask is, do we have an existing building automation system? What is it? Do we want to keep using that? If we want to keep using that, how do we navigate our procurement so that we can? Because there's usually a way to sole source, especially if you have something installed, but you got to get ahead of it. Then, have we communicated that intent to our engineer of record? And have we evaluated what is most likely a boilerplate spec that they're using if it's plan and spec and it's not design build? And we've made sure that it's not something vague like contractor shall provide system. I've literally seen that. Like, what are they providing? Well, it's a system, I mean, it could be like a guy touching two wires together. But that's where your first kind of point of influence is. Then, what I really like to see, if you are doing, like you're a district, you're a university, you're a healthcare system, have standards for your graphics, have standards for your naming, have standards for your HVAC sequences. That's really important because now you only have to train your mechanical staff, your control staff in-house on one type of sequence, one type of graphic, and they can go building to building to building.
Have you seen campuses with point naming?
Oh, absolutely, all the time. Yeah. Like if you go to Northwestern, so if you Google Northwestern control standard, they have a really good one that you can steal. That's the great thing about public institutions is they make everything public. Yes, sir.
The first question should be, why haven't I been invited to the meeting?
Well, yeah, I mean, that's assuming you get to the meeting and you're not actually showing up when the O&Ms are being delivered, which is usually what happens to the facility staff. So, I mean, if we're being real with each other, you all are typically never invited to the construction meetings. Yeah.
Industry-wide, how often is the commissioning agent invited to the SD?
Owner's rep or GC? Like, who's the CX working for?
When public entity, usually the owner's rep.
What's the question?
When and how often is the CX rep being invited, the CX being the owner's rep, not GC, so not working for GC, working for owner, how often are they invited in the SD? Like SD, I don't see them in there very often. CD phase, maybe half the time, definitely during the construction phase.
Yeah, but usually that's after
Yeah,
all the bad stuff has already been designed.
yeah, pretty much. And then the commissioning agent comes up with their own sequence and then yells at the controls people because we're like trying to negotiate it, and they're like, "Why aren't you do it our way?" No, but we got to do it. No, so yeah. But good question. Not enough. But I mean, it all also depends on what the CX's contract is. So CX's commissioning agent, those folks are responsible for validating the owner's intent is being executed, that the sequence is actually being executed, and can come in multiple flavors. There's like random sampling CXs who do 10%, and if they find an issue, then they have rights to dig deeper. There's full commissioning. There's like full functional performance testing. So it just, the whole gamut. All right, so submittals. So contractors, you like to make money, right? This is typically the first way you can make money. So in order to order most materials, in order to bill a project and start getting where you're working off of the project's cash and not off of your SG&A, so not off of your general business cash, is to get submittals out the door and get them approved. It's usually pretty safe if you're at CD 90% to do submittals off of those, but sometimes it's not safe. Essentially what we're doing here is we're taking the mechanical engineering plans, the MEP plans, so those are the drawings. We're taking the CSI sequence of operations as well as the materials, the general, and we're taking all of that and we're putting it into a set of controls drawings. So these will be one-line schematics, controller diagrams, network risers, bill of materials, so IO listing, etc. So this is your place where you're going to take that information, take your understanding of owner's intent, of engineer of records intent, submit it up the chain, either get it rejected or passed, and then once it's passed, you can order materials, so that way you can start charging, you can start putting labor on the job, etc. So really key pivot point. It's also kind of one of your first protections on the engineering side and the owner side to make sure that you're still getting your intent. So if you have the ability to review the drawings, I highly recommend you do it. Any questions? All right, so once submittals are approved, then there's installation. This is an interesting one. So install is dependent on the equipment actually being there. So controls is often blamed for being the last person on the job, holding everything up. And with IP controls, which unfortunately we won't have time to cover here, that's becoming even more of a challenge because the owner's IT network is typically not put in until after certificate of occupancy, which is a whole nother conversation. But installation is we've ordered materials and the contractor either has an electrical sub under them or is self-installing. So for you owners who self-execute, this is where you would be going and executing your work. For contractors, this is where your sub or your in-house install is going to be starting to pull wire, stub things out, get everything put in place. Key points here, validate again the mechanical drawings, where all of your temp sensor runs are going, validate the equipment that is on the drawing is actually what was ordered, that the orientation is correct. As I'll see systems that are improperly oriented and you'll have to repull wire, restub up wire, etc. Those are all like always revalidate and ensure that things still properly represent what is on site. Any questions? All right. We're coming up on a slide where you all are going to learn something amazing. So bear with me here. So configuration. So this is going to be what's called point-to-point checkout. So typically this is like who's familiar with percent of completion, POC? Okay. All right. So basically, it's a metric used in construction projects that is meant to say the project contractually is at this percent complete. So typically at about 60, 70% complete, mechanical equipment is installed, mechanical equipment is started up, and we're going to start to do point-to-point checks. So we're going to literally check one point, which is at the controller, to another point, which is at the device. We're looking for things like proper readings. We're looking for things like proper execution. I want to be very clear because a lot of people get crossed on this. This is not functional test. So for the owners and engineers, if you want people to actually do sequence of operation testing and functional test, you need to specify it. Do realize that will increase the cost because for a controls tech to check a sensor, that takes minutes. For someone to actually drive a piece of equipment and make sure that it's doing the sequence, that can take potentially hours, depending on the equipment and scheduling. Is that clear? All right. So here we're going to do point to point. We're going to go into the controllers, set up their inputs. Some controllers, you set it up on the outside of the controller, some in the software. So we're going to say this is a 0 to 10 input. This is a 4 to 20. This is a resistive input, whatever. So once we've done this, we're also going to set the addressing on the controllers, connect the communication buses, and make sure that we're able to pull the controllers into the supervisory devices and see them. Everyone with me so far of where we're at? Okay, so far we've reviewed the drawings, we've done a release to operations, we've gone and we've actually ordered our material, our electrical or in-house has went and gone and actually wired everything up. Now we've done point-to-point checkout. But they're not a bother. No, I love this. And then I got you. So a lot of people will go and put a continuity tester on the wire. It's like a wireless device that you could put on one end of the wire and then in the other. Or like if you're like I was, where you just have a helper out there and you say, all right, I'm disconnecting it. Are you still reading? And they're like, yeah. Yeah. So you do that. But yeah, I mean, that is a very real problem, especially with some of these new plant controllers that have like 50 I/O on them. So you had a question?
You mentioned that it can be manual or via software.
Yes.
Could I use the term conditioning interchangeable with configuration or is it different?
No, that's very different. So configuration is I go into my controller and my controller is a blank slate. It has no address, no device ID. All the inputs are blank. And I'm going into it and I'm saying, input 1, you're a resistive input. Input 2, you're a 0 to 10 volt DC. Input, they're coming. So when my wife and I were crossing the street, we saw a guy with a 7-foot stick and he had like a knife and he was whittling it, walking across the crosswalk. I was like, oh my goodness. So I don't know. I don't know what's going to come out of the door. So back to your question, the output, you'd go and say, okay, this is a relay output. Because a lot of manufacturers nowadays have what are called UIUO, universal input, universal output, so they can be configured to do anything. And so, for example, on that, you may say this is a relay output. This is a 0 to 10 volt output. So you'd have to configure that. Commissioning would be where you actually go and you say, hey, when I enable this unit and outside air is greater than X, this will happen. And you're doing functional test, you're commissioning. Now, here's the tricky part. Part of commissioning is also point to point. So, like that point to point check, not the configuration, but the point to point check, making sure the I/O is showing up and working, that is part of commissioning. But functional test is most closely associated. When you say commissioning to people, they typically think functional test. They don't typically think point to point. So, yeah, of course. All right, so then we do programming. So this is where the programmer either in the office or on the site will write a program. Some software has question and answer boxes. You just say, is it a unit? Yes. Does it have a fan? Yes. How many valves? 1. And then you fill all this out and you throw the program in there. And then your senior programmer yells at you and says, this doesn't match the sequence. Don't use that free out of the box crap. And then you're like, but no. And anyways, this is group therapy here. So, all right. But what happens is you write the program, and then you put the program with your field tech who will go out there and go and download the program. I'm going to give you all an awesome troubleshooting trick if you are a owner. If you have done nothing to the project and you've done nothing to the facility and you've made, no upgrades, nothing, it's almost never the program. There's no reason for you to be in the program. It's almost always overrides, bad sensors, you did an emergency power test or a fire alarm test and something didn't kick back on or fire dampers closed. There's very rarely, unless you just did a change out or a tenant finish out, there's almost no reason for you to go into the programming. Because if it worked 10 years ago, it's got to be something with the I/O or the electrical or the mechanical. So just free troubleshooting advice. All right. So programming, you write code, or on some of the newer systems, you just select options, especially in the light commercial space. Visualize, what's that?
Programming is part of the submittal, or it has to be done afterwards?
So it's not part of the submittal. So what happens typically is you'll do a submittal. When the submittal's approved, the installation team will go start doing install, and the programmers will write the program. Then, when the installation team says, hey, I'm done, the programmer will either put the program on a share drive or will go and give the program to the technician. So, all right, visualization. At the same time, that person is creating graphics. This is either an in-house designer or this is someone on site. They're creating the graphics on the front end. They're mapping objects from the device. So in order to do graphics, you have to have the controls installed, the I/O installed, point-to-point done, and everything connected to the supervisory device. So then you can map the graphics, you can map the points to the graphic. Make sense? So you're starting to see kind of the logical flow. If I don't have things installed, I can't do graphics. So you all engineers and owners, if you're yelling at the contractors like, hey, go do the graphics, get them done, get the programming done, and there's like not a slab and it's just dirt, I mean, there's nothing we could do. So understanding where things are at in order on a project is very important. And then finally, testing. So this is going to be functional testing. This is going to be where we're testing everything. We typically will stand up a graphic for the test and balance or for the commissioning agent, and we'll go from there. Closeout. This is where we create what are called O&M. So it starts with as-built or red lines. So we will collect red lines from the electrical, we being the controls contractor. We'll collect red lines from the electrical. We'll update the drawings. So the mechanical engineering plans as well as the control submittal. We will then take that information and we will then go and update our submittals. We'll package our submittals, our catalog sheets, and hopefully you get a copy of the graphics in the program files, and hopefully you get the latest backed up database. We hand all that over to you, and that is an O&M manual. As owners and engineers, you can specify this in Part 3 of your general CSI spec, or Part 1, depending on where you want to put it. You can specify what should be in the O&M documents. All right, you ready? This is going to be life-changing. So prepare to be amazed. Scott already knows what's coming because he's seen this like 5 times now. But this is utterly amazing and just awe-inspiring. 100% of the questions that you do not ask are not going to be answered here. I know this is shocking. I know. Lives are changed, babies are born, and it's the time. Whatever questions you have, we've got 10 more minutes. Yes, sir.
So, as an owner, I didn't see something that I feel is very important, is the label.
Absolutely. Yes. So that's a whole subset of things I can get into. That can go into your standard. I personally, back when I ran an ops team, I required color coding. So certain inputs were colored one way, outputs were colored, and then labeling, yes.
Because if you can't go into a chiller plant and run it manually off of the controllers, then you're hooked.
Yes. knowing that you're going to release those overrides as soon as you're done and put it back in automatic and not play the hand game.
But if you lose your BAS.
Yes, true. And also knowing that controllers often will have HOAs on them as well. So don't play the HOA battle where you go over to the motor control panel and put it in hand, and then you go over to the actual BAS controller and put it in hand, and then you're like turning it in hand and your buddy's turning it in hand and you're like, it's off, it's on, it's off, it's on. I've seen that actually. It's hilarious. So, yes, sir.
I'd like to hear some of your comments about the future of field controllers turning into supervisory devices that are turning into servers. What's your thought about the future? Because
Sure.
in the place that I'm working at, we are built out with server and supervisor and field controllers, but we're also seriously looking at, as we upgrade the field controllers, going, hey, let's make it IP and let's
Yeah.
take some steps. I'd like to hear more about that.
Great question. So what I heard you say is from an architecture perspective, what does the architecture of the future look like? I think it depends on the building. So what I think you will see is increasingly physical servers going away, them moving more to cloud servers, visualization layers existing in the controllers and in the supervisory devices. I don't necessarily see supervisory devices going away in the foreseeable future because there's still such a case for BACnet MSTP RS485 comm buses. There's just, when you wire IP, I think it's like a 40% failure rate on wiring RJ45 heads, which that's the head that connects to the 8-conductor IP wire. So you get engineers on the terminal unit side that are shying away from that. But I definitely see IP on the plant and built-up air handler side. Does that answer your question?
Yeah, thank you.
Yeah, you're welcome. Yes, sir.
I'd like to get your input on retrofitting an old existing controls.
Absolutely. So it depends. What I typically recommend to people is there's a really cool, I don't know the product off the top of my head, you'd probably know. It's like a BACnet IP wireless pneumatic stat. Oh, son of a... Well, I'm sure there's something on Temu. So get it before the tariffs. That's all I can say. There used to be products that you could just plug in and you would grab the secondary line and you'd interrupt the secondary line. So you'd feed the main into the stat, and then the secondary pneumatic, so 0 to 15 PSI, would go to the actual actuator. And then it was wireless BACnet. I don't know, maybe there's something, I could probably Google and see, like grab my card, send me an email, remind me, I'll Google and see if I can find something. Yeah. Man, they're not even here to defend themselves. Look at you guys. Like they can't read. They're trying their best, and you just had to do that. You're like, well, haha. It's because they're orange, right? Yeah? Well, yeah. Anyways. All right, what else? This is free consult. You got 5 more minutes of free consulting here. Anything, like stock picks?
Question for you.
Yes, sir.
Something that is often overlooked when reviewing submittals,
Ooh.
comparing with design and test.
Okay, great question. BACnet interface cards on equipment. That is like, who owns that? Is it the equipment manufacturer? Is it the controls manufacturer? What is it? And what control are we doing through it? Are we just doing monitoring? Are we trying to do monitor and control? Are we trying to do the same thing that the controller on the piece of equipment is already doing itself? And we're going and basically like double dipping? That's huge. Another one that I see quite often is actually just, so this isn't really submittal and MEP versus controls documents, but actually putting the riser in a logical order. So oftentimes what people will do, especially like the really lazy designers, they'll do, here's controller 1, and it's typical of 50. And there's no naming, nothing. And so the electrical goes and installs it. First controller's address 1, then he gets a phone call, and then it's like distracted because his wife's yelling at him, and he's like, crap, I'm sorry, I'll put the garbage out. And these are all stories from my life. I hope you're picking up on that. But and then, they go and they address 5 and then get a call again from the kids, and then it's address 9. And there's like no logical addressing because they're just constantly getting distracted. So that's a big one. It's just taking the time to say, this is our addressing scheme. These are where these controllers are at. And then there's nothing that's as fun for facility operators as what I call the game of pop a tile, where you get to walk down the hallway with a broomstick and you get to pop the tile and nope, controller's not there. Oh, nope, controller's not there. And you just get to walk the hallway until you find the controller. So actually putting what room the controller's in, that's another really helpful thing to do on the submittal set. What else? You all have been an amazing audience. Yes.
Just curious, typically, all those, suppose the building is working fine, right?
Yes.
Not fancy controls, and if we implement advanced optimization of the controls,
Yes.
how much energy saving we could expect?
Great question. Very hard to answer without getting into a lot of specifics. If you are a multi-story retail space, multi-story commercial space, and your controls are working fine, you should do nothing. Being honest with you, unless you're in another country where, like Europe, where the kilowatt per hour is extremely high. If you're in Alabama, it makes no sense for you to do any sequence changes. But if you're in, a hospital and you're in LA, then yeah, it could make sense for you to go and implement. There's a lot of really good DOE studies. They've done a ton on doing optimization and actual savings. There's the CBEX database. Do they still maintain CBEX? Do any of y'all know, or did they stop doing that?
2018.
Okay, so it's close. So you can look at CBEX and get a pretty good profile of what buildings' energy usage looks like. So that can give you kind of a snapshot of what your EUI, your energy use intensity, is for the actual market you're in and the vertical. Does that help? Okay, there was one more.
Yeah, just real quick. So you have the system up and running, and
Yes.
you now have hundreds or thousands or who knows, tens of thousands of sensors.
Yep.
And in the name of garbage in, garbage out, if the sensor's not functioning, your program's not going to make the right decision.
Absolutely.
Do you have an approach that you use to recommission or to check the sensors when you have thousands of them and the ROI is not there? It's difficult.
So first things first, use the software. There's some common sense things, right? If you're getting negative 54 or you're getting 312 degrees, you can pretty much figure out what's going on. If you command a system and point status doesn't change, that's a good indicator. So there's some low-hanging fruit that you could do, which is global commands to go and do actual testing. I personally am of the perspective that that's actually high ROI work, because the majority of service calls I have experienced in my life are either I/O failures or disconnected control equipment. It's pretty much 90% of the time that. And so honestly, an operator should be on a semi-annual basis calibrating their I/O. They should be. It will free up time. They will make back probably 3 to 4x the amount of time they put into point calibration.
That's called continued commissioning, right?
Kind of, sort of. So continued commissioning, it depends on who you ask. Basically, that can be, point to point. Usually it's more like functional test. So it's actually stroking to make sure that the sequence is operating. So, yes, sir.
When you say
Both. All of the above. Or it's even in software in hand as well. Yep. So, one more. Yep.
Following up on that continuous commissioning, any thoughts about analytics and fault detection coming into the BAS world?
They've been talking about it since I started in the industry. And it's been the same talk and same thing. I think it's a cultural and a system issue at the same time. So cultural in, let's be real, a lot of people don't want people to know what they have and haven't been doing. I literally did a large government building in another state where there was a 4x4 foot hole in the side of the building. I knew instantly we weren't selling analytics to that building, but hey, we were already there, so we tried. So culturally, there's that issue. And then system-wise, so there's no naming standards at most buildings. The systems still don't have a good way of determining what they're looking at. And without that, it's very difficult to go and implement analytics or fault detection. Plus, you just have to get people to adopt it as part of their process. And most people are, like, I went to a very large seed manufacturer, so you'll probably be able to figure out who this is, that creates seeds for farmers. And they had a chiller down, but they didn't know because they had 50,000 unacknowledged alarms. It was nuts. So they lost a whole test that they were running on a growth. Until that stuff's fixed, I don't see large corporate customers adopting it. So we're over time. I mean, do you have anyone in here after me?
Well, we're 30 minutes till the next session. If you want to go a little longer.
I don't mind. I'll sit here and answer questions. It's fine. Anyone? I have cards up here, by the way, if you want to learn anything more. Feel free to grab them. Thank you.